Let's continue with the test 2 review, chapter 20. So the first thing in here, properties of resistors in series and parallel, it's talking about these equations over here, that if you have resistors connected in series, so it would look like this. As long as you just have one loop, one wire connecting them, there's no junction, there cannot be a junction for them to be in series. Then you know that you have current flowing through this circuit. There can only be one current. It must be the same for the whole circuit. That's what this says right here. The equivalent resistance is more because you have to use this equation. So this is talking about if you were to simplify this resistor, this circuit, and draw a circuit that just had one resistor, then this would be the equivalent resistor and its value would be more than either of these two individual ones. And also the voltages add, you do have to know that. So if these are unequal resistors, then if, for example, you've got 9 volts here from the battery, then maybe you could have 5 volts here and 4 volts here. And those two voltages would add up to the 9 volts. But what this is also saying is that the voltage across this equivalent resistor would also be equal to 9 volts as well. And then for parallel circuits, so you want to identify your resistors as being in parallel. The way you do that is you make sure that there has to be some junctions, and you've got the left end of one resistor connected to the left end here, and you've got the right end connected to the right end, and there cannot be anything in the way. So you see here you've got these ends connected, but you don't have these ends connected because you've got this in the way. And for this to happen, you're going to have two junctions. So if there's junctions, it could be in parallel. It doesn't have to be. It could be nothing, right? If you had something like this. Then you don't want to say that just because that there's junctions, it's in parallel. This would not be in parallel because this battery here is in the way of these two resistors being connected. But if there are junctions, then it cannot be in series. So if you were to simplify this circuit to one equivalent resistor, like in here, then the delta V across each of these would be the same as the delta V across the equivalent resistor. That's what this is saying. And this equivalent resistance would be less than either one of these two because you have to use the 1 over equation. And remember the shortcut, if these two resistances are the same, then the equivalent resistance would be half because you would be doing 1 over R equals 1 over R equivalent equals 1 over R plus 1 over R. And these two R's are these two R's, assuming that they're both the same. So this would be 2 over R. And then if you flip both fractions to solve for R equivalent, you get half of the original resistance. You could even do this if there were 3 resistors in series, or sorry, in parallel, right? So if you had a third one here, let's see. If you had a third one here, and they're all identical, and you're trying to find the equivalent resistance, well, just add another one. With these equations, you can add as many resistors as there are. You don't have to do 2 at a time. You can do 3 at a time, 4 at a time. And this will give you 3 over R. So then if you flip it, you get that the equivalent resistance of these 3 in parallel is 1/3 of the original resistance.